All right, I got that taken care of. Okay, so once again, my name is Julian NOAA, scholar from Jackson State, and today I want to talk to you all about characterization of microplastics and Lepidophthalmus louisianensis, ghost shrimp on Mississippi Sound. First, I know you all already heard it. I want to tell you all a little bit about microplastics. So microplastics are small synthetic polymers ranging from size of 5 millimeters to about 0.01 millimeters. And they've been known to contain chemical compositions that can impact marine species. And they also impact the marine food web. One species I chose to look at was Lepidophthalmus louisianensis, which is the ghost shrimp. And they're located from South Texas all the way to Central Florida. And they live in low saline sand settlements. And one reason why they're actually so important is because they're major prey to some species that we know of. Okay, there we go. All right, so the species that we know of are the sturgeon, stingrays, and shorebirds. And these species, according to the Endangered Species Act, are threatened species. So one reason why I decided to look at Lepidophthalmus or ghost shrimp is because they live in these burrows right here. Here's a burrow right here, and here's one right here. And they dig deep in there, and they can dig as far as 6 feet deep if they so choose to. And from there, we've always thought that they were filter feeders based off their mouth parts. However, some evidence has shown they could be deposit feeders. So I wanted to test that out to see the amount of microplastic exposure that was in their gut and gills to see if they could be deposit feeders or filter feeders. So my study area was in the northern part of the Gulf of Mexico. And I chose Ocean Springs, which is located right here. Here's a blow-up picture of it. And Ocean Springs, located on the right, with Biloxi Bay being right here to the left. And the reason why I chose this site was because of the mixture of habitats that surrounds it as far as commercial, residential. And there's two beaches that I looked at, Front Beach and East Beach. Now, I chose 2 test sites for Front Beach, right here, Front Beach 1 and Front Beach 2. And I just chose just 1 test site for East Beach. And the way I went about doing this, I did 3 transects, 3 depths per transect, 3 replicants per depth, which was total 27 samples per site. And I used a stainless steel core. And what I did with that, I used that to collect 5 by 15 centimeters of sand sediment. And from there, I placed it in a whirlpool pack and placed it on ice. And from there, to collect my ghost shrimp, I used a stainless steel gas pump for the ghost shrimp sample. So, with the ghost shrimp, so I placed those on ice too, and I returned them back to the lab at Jackson State. And from there, I returned them to the lab and I let them thaw. So once they're completely thawed, I digested separately the gill and the guts, and I placed them into 2 separate 250 milliliter beakers. And I also added 30% of hydrogen peroxide, which was actually 50 milliliters of hydrogen peroxide. And from there, I placed them inside a incubator shaker. And the incubator shaker had a temperature of 6 degrees, 50 degrees Celsius. And it took roughly about 24 hours for them to dissolve completely. And from there, I moved on to sand sediments. So with the sand sediments, I transferred them to a 1 liter jar. And I placed them inside a drying oven, which was about 6 degrees Celsius. It took roughly about 48 to 72 hours for them to dry completely. And once they dried completely, took them out, I homogenized the sand, and I measured about 50 grams of sand, and I placed them into a sediment microplastic isolation unit. Now, I got this method from Topic and his colleagues from Harvard. And basically what this does, it helps to extract, it helps to separate microplastics from sand sediment. And it does this by having a mixture of a solution, a dense solution. the solution I used was in chloride. It had density of 1.6 grams per centimeter cube. So here's an example, just a little drawing of how it works. So basically, I would place 50 grams of sediment into the SMI unit. I would stir it up using magnetic stirring rod. And basically, I wait about 5 minutes and I would turn the stirring rod off. And I would just let it sit, which would allow for my plastics to go to the top. And from there, I would just close this valve right here. And then I would filter it with a 0.7 micron filter. All right, so from there, I put it into the drying oven, and then the next day I would look at it on the microscope. So when I would look at it on the microscope, what I noticed was that it was a lot of this like sand sediment that was here. And most of the time, just our first glance, we would think like this little thing right here, we would think that was a microplastic. But after close examination, it's just wood. And also here, it was glass. Okay, yeah, right. It was like this glass fiber you see right here. But now, even though it was sandy like that, that doesn't mean we didn't find microplastics. I did find a total of about 143 microplastics. And as you can see here, there was a microplastic located here on the sand that I had to find. And it was one also located here, and as well as the ones that were located here. So after these microplastics were actually counted out, I had to see if there was a correlation between them. Just see if there was a correlation between the amount of microplastics in the gut and also in the yield. And what I found was it was low correlation. So from there, we begin to think, okay, so what is the correlation between the amount of microplastics within the shrimp as far as the guts, gill, and the shrimp as a whole compared to the abundance of microplastics in the sand cell of each cell. And from there, we saw it was also another low correlation. So then we're like, okay, we said, back up. So we said, okay, let's see if there's maybe a difference between the beaches. So from there, we ran a NOAA with a pulse ox test, and we did find there was a difference between the beaches. One of the main differences was the fact that Front Beach 2 had fewer microplastics when compared to Front Beach 1 and East Beach. And this is why I hypothesized on why that's the case. With Front Beach 2, why the reason why I had fewer microplastics, it's mainly because in Front Beach 2 there's a lot of erosion. So from there, I'm just assuming that the microplastics here that were left here in the settlement, that they were being pulled away from they were being placed in the settlement and they were being pulled away from tides. So that's why they had fewer microplastics when you compare it to Front Beach 1 and East Beach, which had abundant microplastics. So then we begin to think, okay, so how are these microplastics deposited around the beaches? So then we started looking at the depth. So again, we did the NOAA pulse ox, and it did show that there is statistical difference with depth 1 compared to depth 2 and depth 1 compared to depth 3. And so we were thinking, okay, that kind of makes sense because when you go back to it, depth 1, it was located on a swash zone. So with that being the case, microplastics, they float like in these dense areas. So when compared to seawater, it's dense. So depth 1 had the most, it was less dense, so it allowed for the microplastics to float in that area. So a big takeaway that we took from all this was that the fact that we did not find like a significant correlation between the amount of microplastics in the gut and gills of the shrimp, and also the shrimp as a whole when you compare it to the abundance of microplastics. But we did see statistical difference within the beaches, with Front Beach 2 having fewer microplastics, and also with depth 1, it was shallow, so it had the most microplastics there. And it brings back this question as far as like the potential of what microplastics could do. Like I said, we did not find out if the ghost shrimp were filtered or deposit feeders, but we did find microplastics were there, and also within they were there within the depth of the shallow of the swash zone, and then they were also being pulled away from tides with beaches that are eroding. So it's just one new question that we have about what microplastics could do to marine species, and if it's impacting marine species' food well, it could potentially do to us as well. I think you want to listen.
So just want to make sure this is right. You grabbed ghost shrimp from all three of the sites, correct? Did you find that either site had more plastics inside the ghost shrimp?
So yeah, so the thing about that was it was random. So you had some shrimp that had microplastic water had more on the gills, and then you had some that they had on the gills and they had maybe like 1 or 2 in the gut. So it's kind of all over the place. So it was so much local population, I just can't say that okay, this one had more or this one, this one, less than that.
Mm-hmm.
So does that have your question? Okay. Okay.
Really cool talk. I was wondering, did the bigger shrimp have more microplastics? Did you see an effect of size on the amount of plastics in the shrimp?
No, you had some that were bigger that had like 1 plastic, and you had some that were small that might have had just 1 or maybe 2. They kind of were just, like I said, randomly like that. Some didn't have any at all. So,
I think it was a follow-up with the first question. With the data that you have now, are you able to make or observe the correlation between gold shrimp abundance and microplastic concentration, and basically observe a response to microplastic concentration, seen from the gold shrimp?
yeah, like 3 questions.
So basically, I just want to know, with the data that you have right now, are you able to observe a correlation between gold shrimp abundance and microplastic concentration?
All right, so that one, no. So that one, the answer is no, and it's basically about how the way that I did this method. So I kind of rushed this method times or something, and I had to go back and do it again. I'll definitely do it again, and I can answer the question from my brother. So
That's cool. I love unanswered questions, man. That just means another experiment.
Good talk, bro. Congrats. I wanted to ask you, will someone be looking at the human dimension factors such as like beach nourishment or any like industrial activities that lead to those microplastics being in the area that you're studying?
yeah, so that's for someone to look at. I really didn't look at that. Something I have to look at someone to see if they do it.
Oh, yeah, that was
a question. So yeah, I got all that back here. Okay.
All right, that's a follow-up question from the person just in front of me. Did you notice any differences just in the depth of the ghost stream from your erosional versus your non-erosional depositional beaches and what depth they are actually sitting on, which might explain some of your differences?
Yeah. So if you ask me, I think you asked me. So the erosion, I noticed that. Okay. So those ghost shrimp, they did have fewer microplastics from that area, as far as like the replicants that I did collect, just from beach 2. So they did have lesser microplastics, and that could be to the fact of them being, like I said, being pulled away, because them being pulled away from the beaches, mainly because from the coastal waters. Now, it could be the fact that also some of those microplastics are sinking down into the burrows of those ghost shrimp. That's one thing I feel.
I was wondering if you all are planning to like sample the water columns, like the plankton films and such, to see if maybe plastics are coming. Yeah, from there.
Okay. So that's something to deal with that. It wasn't ideal. But like I said, I was rushed. So,
Yeah.
Yeah, so I kind of move on this, but that's something I feel with too.
Is there any way to like manage the plastic issue? Maybe like some kind of point source analysis where you can look at where the pollution might be coming from like the surrounding area, and then try to implement some kind of like regulatory or like management strategies?
Yeah, so basically, hypothesize that most air pollution, besides the one that's coming from the coastal waters, figured most of it's come from us when we visit the beach. We actually see those plastics there, then they grade down to microplastics. So as far as like policy, you know, they try to do something with food. That's really all that we could do. And then of course, you know, just talk to city officials, let them know dangers and everything. And microplastics would cause species and also.
You know what the gut residence time of particles are for the ghost shrimp? Do you know what the gut residence time of particles for the ghost shrimp is? By any chance? How? Nope, it's not in the literature yet.
I don't care as much about that animal. It's any bird to make it.
Yeah, we don't even know what it cares.
What about the elephant in the, how does this affect us in the shrimp?
Okay. So basically, like I said, microplastics, they can transfer within the food pattern. So for instance, you eat shrimp, or if that shrimp is a predator, and it's the microplastic transfer onto us, which basically shows that microplastics are in the bloodstream now. So it really transfer to us some kind of way.
Okay, thank you, Julia.